All right, so ladies and gentlemen, what I'd like to do is just kind of go over a basic definition of prime numbers, because it's going to be very important for what we're going to be doing today. All right, so basically, ladies and gentlemen, prime numbers are numbers that only factors are the number itself and 1. So to understand this, though, we need to understand really what factors are. What exactly when we say factors, what exactly do we mean? So does anybody want to offer up their definition of a factor? Yes, Sean.
Number that can go into a different number.
Yeah, it's a number that can be divided into another number. So anytime you have a number that we could say is divisible by a factors. And the way I also like to think about factors is, think back to when we were factoring, polynomial expressions, which we'll go back over again this year. When you're factoring, basically what you're doing is you're taking an expression and rewriting it as a product, right? So all factors, since they're divisible into your number, can be rewritten as, or all numbers can be rewritten as a product of their factors. So a prime number is one that the only way you can write a multiplication problem is that number times itself. So for instance, an example for this would be the number 3. The only way we can write 3 as a product of two numbers is 3 times 1. Right? You can't write 3 as two integers. Right? You could always do fractions. But you cannot write anything else except for 3 times 1. The list goes on and on, right? There's tons of different prime numbers, all right? But in a non-example would be like the number 6. Well, yes, you can write 6 as 6 times 1. But we could also write 6 as 2 times 3. So therefore, 6 is not a prime number. All right? Only numbers the only two numbers that divide into that number are itself and 1 are prime numbers. Cool? OK. So if it's not prime,